So yesterday you watched that video on slope, Khan Academy. Let's go to officially, formally define what a slope is now. What is the slope of a graph? I'm going to write this down. Try to erase this garbage. Thanks for laughing. Appreciate that. The change in vertical units for every horizontal unit on a graph. The change in vertical units for every horizontal unit on a graph, it is also referred to as the rate of change, or simply the rate. Give you about a minute to copy that down. Now when I say vertical, by the way, does that mean up and down or left to right? Nice. So if you forgot what vertical means, maybe next to it, maybe put an up and down arrow just to remind yourself that vertical means up and down, and the horizontal would mean left to right. Just as a personal reminder, if you forget what vertical and horizontal, the distinction between the two, you might want to do that on your notes, because your notes are your notes, so you don't turn them into me, it's for you. I'm going to write that down. Khan Academy threw the formula at you as the first question on that video yesterday. Do you remember the formula for the slope? It's always referred to as lowercase m. In other words, I think it came from the French language. Slope in mathematics is conventionally, like as a rule of thumb, it's always referred to as lowercase m. Remember your math 1 days, y equals mx plus b, m referred to the slope. M is always, it's kind of like the agreed upon variable to represent slope. The slope is always something over something. You remember from the video yesterday, extra magic card if someone can remember and just blurt it out. Rise over run, but more specifically, more maturely, more, what's the word I'm looking for? More sophisticatedly. Something change over something. What? So there's a Greek word, a Greek letter with a triangle. The triangle, say again? That's another Greek letter. That's for 3.14, but this was a different Greek letter. Right. This is a Greek letter. Change in, so delta y, change in y over change in x. Write that down, please. Yeah. Thank you, Cepeda. You cleared it up for us. So this letter in the Greek alphabet is delta. Okay, this is a letter in the Greek alphabet. And mathematically, it's come to mean the change in something, the amount of change between two somethings. So the change in y over the change in x. Back in the day, when they would introduce it to you in junior high and lower math, they'll say rise over run, which is good. But this is the more sophisticated now. Thank you, Soto. This is the more sophisticated way of articulating slope, delta y, delta x. But it is still rise over run. But now we're Math 3 students, so we've got to see it more maturely and articulate it more sophisticatedly and more professionally. In other words, you'll see this when you get to college or even calculus class. The same slope formula, delta y, delta x. Now, on your notes, just go to what change in y. Change in y over change in x. Just to remind yourself that all that delta, this delta letter means is change. It all means the same thing. The change in y or the change in x. So far, so good. We'll do 2 simple examples, and we're done with our notes today. It's easy. By the way, it's also referred to as a rate. The rate. So slope is a rate. The rate is a slope, slope is rate. They mean the same thing in math. Allow me to elaborate. Example 1. Go ahead and copy this graph down on your graph paper. Just look at from 0 to 48 to 50 to 52. And then go from 0 to 10 to 20. Just make a quick, simple graph on your graph paper and then draw the line that you see. Doesn't have to be some Picasso drawing. This is your notes. This will be on video, so don't stress out too much on the quality of your drawing. Just try to get this down on your notes here. So I got cost in dollars as my vertical axis, and I got the number of texts as my horizontal axis. This is some type of cell phone cost for some type of company. I'll give you about a minute to draw this. Go ahead. The mission is find the rate. Find the rate. But I just told you what the rate was about 3 minutes ago. What is the rate? It's a slope. The slope is the rate is a slope. It means the same thing in math. What is the rate for text, the cost for text? How many dollars per text? That's what we're about to find out. How many dollars per text? How many vertical units per horizontal units? Look at the way I said it. Dollars per text. Vertical units for every horizontal unit. Vertical over horizontal. Dollars per text. Let's do it. Go and write M equals delta X over delta Y. The change in X over the change in Y. My bad. Coffee hasn't kicked in. Good looking out. What is extra magic card? Delta Y over delta X. What's the matter with me? Jeez Louise. Si cielo from Guatemala. Maybe I should change a different one. Or drink some more, one of the two. Here we go. Delta Y. I'm going to find the change in Y values. Watch this. I got 2 points that we highlighted. So this example came with 2 highlighted points on the graph. It came with 10 texts is $51. 0 texts is $50. Think about that. No text on this cell phone plan, you're already paying $50. So it's probably a month, $50 a month, and then every 10 texts, it seems like every 10 texts you pay a dollar, huh? So how much money per text then? Per one text. Well, let's find out. Let's see. So delta Y is the change in Y's. Look at this is a Y value, and that's a Y value. Hold up. The X's are the 10 and the 0. X, Y, X, Y. So let me go ahead and subtract. To find the change in Y, to find the change between any 2 values, you subtract those puppies. So I'm going to subtract 51 minus 50. Watch this now. That's the Y's. Look at 51 minus 50. Stay with me. And notice I picked 51 first. I didn't have to pick 51 first. I could have did 50 minus 51. It doesn't matter which ones are first. What does matter is that if 51 is first here, then that means 10 has to be first when I do the delta X. So since I use this ordered pair first as 51, that means when I do the delta X, 10 comes first. Look at 10 minus 0. Watch this. Watch this. Let's do the math. 51 minus 50, I want to say is 1 if my coffee is kicked in. 10 minus 0 is 10 if my coffee is kicked in. So what does this mean here? Well, right now, I like where you're going. Watch this. What did Y represent? Dollar. So this is $1 per 10 texts. But we don't talk that way in real life. We want it something per one something. In other words, how many dollars per one text, not per 10 texts. So here's what we're going to do. We're just going to do the division. 1 divided by 10. In other words, 10 divided by 10 is going to be a 1 denominator, 1 text. And 1 divided by 10 is 0.10. So look at what I did. All I did is to make the denominator a 1, I just took 1 divided by 10. See, 1 divided by 10 on a calculator. Let me get my calculator out, just for those of you who are rusty with decimals. Look at 1 divided by 10, 0.10. In other words, a tenth of a dollar, which is actually a dime, 10 cents. Good job, Alfaro. So, technically we were done here, $1 per 10 texts. That's the rate, but we don't talk that way in real life. We want to know how many dollars per one text. It's actually $0.1 per one text, which is 10 cents per text. So our final answer, more professionally, is going to be 10 cents per text. Look at the way I write it. Per one text. Or $1 per 10 texts. It's the same thing, same rate, same amount of money. One more time? Yes, exactly. Whenever you're dealing with the business world or transactions in real life, it's always something per one something, not per 10 something. That's why I had to go the extra step. 1 divided by 10 is 0.10. So 10 cents per text. This is the way you're going to do your assignment 34. You go the last mile. One more example. Last example. I'll give you about a minute to copy this one down. So I could tell as the time increases, the distance decreases. So I'm not sure what's moving or is it a motorcycle, a scooter, a bike, a skateboard? I don't know what's moving. It doesn't really matter, but chicken. Whatever. A chicken? Whatever is moving, the more hours that pass, the less miles, the less distance there is between the observer and the object. How is that possible? I thought the more amount of time you travel, the more miles is going to increase. Why would miles be decreasing as time would increase? What kind of situation would involve?
You're getting closer to your destination.
There you go. You're getting closer to your destination. The distance between your destination is decreasing. The more hours you drive, very nice. Or the object is coming towards you, so you and the object are decreasing. Either way. Go ahead. All right. Let's find the rate. Last one. So find rate. That's slope. Slope is rate. Rate is slope. Delta y, delta x, rocking and rolling. All you need is 2 points on the graph. And the cool thing is these examples I just gave you, they highlight 2 points already for you. Later on, I'll throw a graph at you and you highlight any 2 points you want. It doesn't matter what points you use. It all comes out to be the same in the end. It's kind of weird and mysterious that way. Okay, so the 2 points they gave me is at 0 hours, the object is 360 miles away. Look at 6 hours, the object has reached its destination. It's 0 miles away. So those are 2 points I'm using for my delta y, delta x. Cool. So my y values are the 0 and the 360. Look at, I put a y over both of them. My x values are the 6 and the 0. Put an x over the both of them just to remind me of which ones are my x and which ones are my y's. Questions so far?
No.
Okay. So delta y. 0 minus 360 or 360 minus 0 does not matter. Let me say it again. Which y should come first? It doesn't matter. I'm going to go with 360 minus 0 just to make it easier for myself. I have a positive answer on the top. Look at delta y, change in y, subtract those puppies. Now the change in x, I'm going to use this ordered pair first because I used 360 first, so I got to stay consistent. The first x is 0 then. The second x is 6. Let's keep going. Again, I could have went the other way around. I could have put 0 minus 360 and then 6 minus 0 at the bottom. Doesn't matter. It's still going to be the same rate in the end. Trust me. Question so far? Let's rock and roll. So let's see. 360 minus 0. I want to say it's 360 if my coffee is kicked in. 0 minus 6 is a negative 6. So there's your rate. So whatever's moving, it's a chicken, a skateboarder, a fast car, I don't know what's driving, doesn't matter. It's traveling at a rate of 360 miles for every 6 seconds. Or 6 hours, my bad. That's a fast car, huh? 6 hours. But that's not how we talk in real life, do we? We talk about miles per hour, per 1 hour. MPH, miles per 1 hour. So let me go and do the division now with my calculator. Watch. 360 divided by 6. So it's going to be so a positive divided by negative is going to be a negative rate, a negative 60 miles per hour, MPH. Look at that. Because this becomes a 1 hour, and this becomes a 60 miles per 1 hour, or miles per hour. That's the way we talk in the real world. And it's negative because the distance is getting smaller. So it's a negative distance, a negative rate. It's moving closer to you, or you moving closer towards it. One of the two. Doesn't matter. So when you're on assignment 34, you need to make that denominator a 1 by doing the division, going the last step and making it into this. Please be aware of that.